Okie dokie. So this first problem is just recognizing which one of these angles they're given, the x, the y, the z, which one is exterior, which one's interior. Well, the interior one, that's probably the easier question, right? That would be z. The only angle that's inside the triangle is z. The exterior one, that's the one that might be a little tricky, because you look at this, you see, oh wait, this x is outside the triangle. Isn't that exterior? No. Notice that the y got created when you extended aside, not the x. So actually the y is the exterior angle. X is called the reflex angle. Now, this is why it's a good idea to be familiar with the proof. Remember when we did the proof? We had the linear pair, and so y plus the interior equaled 180. If you wanted to find the angle here by B in the triangle, you'd have to subtract from 360, not 180. Okay, and that's the reason why, really, why is the exterior angle. Okay, now this one. Notice you have the parallel line markings. So again, getting used to the geometry. So that's going to be a big help. Notice we also have a linear pair with this little slither of an angle above the A. And then we'll be able to determine what they want us to find, ACD, which is this angle down here, exterior to the triangle. Okay, so I labeled those 1, 2, and 3. Okay, so we want to find X. Okay, well, we can get angle 2 because 145 plus angle 2 is 180. And now we got angle 2. And angle 2 and 3 are alternate interior. Which means they're congruent. Oh, sorry, I say angle 2 and angle 3, my bad. I'm looking at the number. So angle 2 and angle 3 are alternate interior. Okay, so then angle 3 is also equal to 35. All right, now once we get angle 1, then we can use the exterior angle theorem to find x, which would be the sum of angle 1 and angle 3. And notice how we're going to get angle 1. That's a full circle. And we already know angle 2, so we're going to subtract from 360 to get angle 1. And that's because it's a full circle. All right, and so let's see, I think 92, yeah, so angle 1 is 92. Okay, so notice we're using all of these properties of geometry that we've been trying to learn to solve this one problem. And now we get to the geometry property we just started today. X is an exterior angle to the angle 1 and 3. Okay, so then X equals to the sum of angle 1 and angle 3, which means 92 plus 35. Okay, and we'll look at the third problem in a moment. So for the second problem, we used a linear pair to get angle 2. And then we got angle 3 because we had alternate interior angles since the lines were parallel. And then we got angle 1 by using a full circle, since we already had 3 of the 4 angles known. And then once we get angle 1, we could use the exterior angle theorem to find x. Okay, in this next problem, now notice that the 132 is an exterior angle. We have these geometric markings implying that BE is a bisector of an angle, so those two are congruent. And we want to find the angle here at BEC, which is the top part of the lower triangle. Okay, so I labeled those two angles 1 and 2, but we already know angle 1 and angle 2 are congruent. So they're the same. All right, the key to this problem is recognizing that 132 is exterior. If we just use the smaller triangle, then the x in angle 1. If we use the larger triangle, then the 43 and the angle there are exterior or interior to the exterior angle. And since those are both the same, once we find that one, we can divide by 2, and then we'll know what angle 1 is, and then we could use the exterior angle theorem with x in angle 1 with the 132 again. So we're going to use the exterior angle theorem twice. Okay, so 132 is going to equal 43 plus, because these two combine to be that one angle. Again, if you just look at the larger triangle. Okay, so then we subtract 43 and then divide by 2, since those are both the same. Okay, and when you do that, you wind up getting a decimal, which is 44.5. Let me double check. Yeah. Okay, so that's what equals angle 1 and angle 2. All right, so now we know angle 1, and now we can use the exterior angle theorem again, just using the smaller triangle on the bottom. Okay, so then 132 equals x plus angle 1. And then finish the problem. So very helpful. If it wasn't for the exterior angle theorem, that would be a hard problem. So that's one of the reasons why we use that theorem. It simplifies what would normally be more challenging. And that's how we did this problem. We did the exterior angle theorem twice. So with the bigger triangle, that angle, and 43 is exterior to 132. Well, that angle, I just labeled it A. That's the combination of the angles 1 and 2, which are the same. And so when you subtract 43, you just divide by 2, because those are both the same. And now we got the value of the angles that are on the lower right side of the diagram. And so then we can use the exterior angle theorem again based on the smaller triangle. So x and angle 1 are the opposite interior angles to the exterior 132. So that's going to be in this equation. And then we just solve that equation. Okay.